So the flight director bars can be displayed provided the heading vertical speed selected on the FCU and automatically selected at system power up. So when we power up the system, guys, the heading vertical speed is automatically selected. At certain system configuration changes, the FMGC send the command to the DMCs to make the flight director bars plus for 10 seconds. The autopilot flight director modes are correctly followed when the flight director bars are centered on the fixed aircraft model on the PFD. There are 3 flight director bars: the pitch bar, the roll bar, the yaw bar. The horizontal pitch bar can be displayed if the vertical mode is active except during the rollout phase of the landing. The vertical roll bar can be displayed if the lateral mode is active. Below 30 feet, the radio altimeter at takeoff when a localizer signal is available, and during landing, the roll bar is replaced by a yaw bar IDEX. We show this also, guys, with the video. So this bar is then centered when it is just below the central yellow square. This is the central yellow square that we spoke. So the flight director, the flight path director and the flight path vector symbols can be displayed provided track flight path angle is selected on the FCU. You remember, guys, the push button that I showed before. So this one, what it makes. So exactly this is what they describe us. So the autopilot flight director modes are correctly followed when the flight path director and the flight path vector symbols are superimposed. The FPT, the flight path director symbol, supplies command signals to intercept and fly the lateral and vertical flight path as defined by the Flight Management Guidance Computer, FMGCs. The FDP symbol is removed if no guidance mode is provided by the FMGCs. Guys, so the flight path vector symbol presents lateral and vertical flight path informations. And in terms of current track and flight path angle actually being flown, the flight path vector symbol position is computed by the Air Data Inertial Reference System, ADIR. Let's see, this is the FPV, guys, the flight path vector, which is the ADIRUS, in this case computed from the ADIRUS. And we can see that we have also the flight path director, which is coming from the FMGCs. So the FMGCs show us the FPD, the flight path angle, the flight path director, and this one, it gives us the flight path vector. The ADIRUS give us the flight path vector. Note that the yaw bar is identical with FD bars, flight director bar, case, and appears with the same conditions. Let's see this small also video to get better. The auto thrust. So this is how it works. The FMGC It sends the information to the FCU. For what, guys? To increase or decrease the speed of the aircraft. This will work if the auto thrust push button is on. So if the auto thrust push button is not on, what will happen is here? The switch will not close the circuit, and as you can understand, it will never go to the EIU and to the FADEC. But to send, it needs to pass through this FMGC bus choice logic and after to the FCU process selection logic. The selection is if the auto thrust is on or off. It will pass, as you can see, the FCU. It's not only one device, it has two FCU1, FCU2, two channels. Okay, guys, and this is for sure, if it doesn't work, at least to work properly. So the auto thrust function sends and compute thrust command, which is the thrust target, to the FADEC. But to go to the FADEC, the auto thrust function, what is? Acquisition and holding the speed or the Mach number, acquisition and holding of the thrust, reduction of the thrust to idle during descent and during flare on final approach. Protection against excessive angle of attack called alpha floor protection by ordering a maximum thrust when the alpha floor detection signal is received from the FAC. Auto thrust loop principle. To get auto thrust function, the thrust target computed by the FMGCs is chosen by the flight control unit, the FCU. Then each FCU processor sends analog its own bus, the thrust target to the FMGCs via the engine interface units. The auto thrust engagement, the engagement of auto thrust function can be manual or automatic. The auto thrust is engaged manually by pressing the auto thrust push button on the FCU. This is inhibited below 100 feet radio altimeters with engine running. The auto thrust is engaged automatically when the autopilot flight director is engaged in take off or go around mode, or in flight when the alpha floor is detected. This is inhibited below 100 feet radio altimeter except during the 15 seconds following the lift off. Okay, this is what we spoke before with Mohammed. When the auto thrust is engaged, the FCU auto thrust push button is light. The engagement status is displayed at the flight mode annunciator FMA here. Speed, auto thrust here. Sorry. When engaged, the auto thrust can be active or not depending on the position of the thrust levers. When engaged and not active, the thrust control is manual. The thrust is commanded according to the position of the thrust levers. When engaged and active, the thrust control is automatic. The thrust is commanding according to the auto thrust computed thrust target. The auto thrust disconnection, we spoke. Auto thrust disengagement can be manually or automatic. Auto thrust is manually disconnected either by pressing this instinctive disconnect push buttons or by setting all the levers to the idle position, or if you remember, above the climb. So it will follow the thrust levers above the climb and to the toggle also, or through here this push button that we have, the auto thrust push button at the flight control unit. Auto thrust is automatically disconnect in case of a failure detection, of course. FMGC1 guys, give the information here we can see because also the FCU has two channels, FCU1, FCU2, FMGC2 send it to the FCU2, FMGC1 to the FCU1. And after we have the engine interface 1 from the engine 1, engine interface 2 for engine 2. After EC for the V2500 or ECU for the CFM56, the same is for the FADEC 1 or FADEC 2. So this is, guys, the auto thrust off, okay, auto flight, auto thrust off. So somebody push the push button to the off position. Also, this is the active, as I told you guys. This could be active if you place it to this position. If you place it, this is for only one engine. So if you place it here, the flexible max continuous thrust, the autopilot will be on. But if you have only two, or if you have two engines, if you place it above the climb, it will be off the auto thrust. Okay, not active. Do you have any question, guys? Any question until now?
Yes, I have a question. Hello, sir. Can you hear me?
Yes, tell me.
Yes, I didn't understand well. Please repeat on this. There's two things you said where the auto throttle is inhibited. Please repeat and so that I can understand.
The last one that I say now.
Yes, yes, yes. Wow, the auto throttle. When cannot be engaged automatically, or when is it inhibited?
Look, if you place the thrust here, your thrust lever, until the
Yes,
climb here, the auto thrust can be okay, can be engaged,
yes,
active.
yes,
But if you place above the climb here, at this position, here, at
yes.
this position,
Yeah,
the auto thrust will go out. So, oh, bye-bye
yes,
auto thrust, you demand the engine
yes,
to increase the speed. From
yes,
here, from the climb and above, you don't have auto
yes,
thrust. But if you place
yes,
also the thrust levers to the idle, you place
yes,
it to the idle,
yes,
also the auto thrust will go. Okay,
yes,
and here, this is what I told you. In case that we have only one engine,
yes,
okay, you have only one engine. And in this case, what happens? You lose this engine. If you place the one lever, the flexible max continuous takeoff, because you need more thrust, the aircraft to fly direct, to not lose a lift. So in this case, if you place it to the flexible here until flexible max continuous takeoff,
yes,
it will not go to the auto thrust, will not leave, you will not lose it. You will have it if you have only one engine active.
yes,
So
yes,
if you place it after from flexible max continuous takeoff to the toga with a single engine, when you have only one engine, then you will lose it. You get it?
yes.
And now, guys, I don't know if you like Italian cuisine. I don't know. The Italian cuisine has a lot of spaghetti. So yeah, unfortunately, here is the best spaghetti that you can have, Napolitan. So if you are hungry, just you can see a video like this, Spaghetti is everywhere. If you are not hungry, okay, doesn't matter. Just try to follow me if it's possible. We already spoke about it. You remember who is the spy? CFDIU.
CFDI.
Bravo. Where is connected?
Fault isolation detective system.
Bravo.
Pakwan.
Bravo. And after you see the fact what it has to
Command and monitoring.
exactly like almost all the computers. They must command something and they must monitor also if it follows the orders. Okay. So they are connected here. They communicate together. And who is the boss of the system? Let's see. The boss.
Right.
But what fact? What the fact?
Pakwan.
One.
One. Yeah, Captain. You see? Fact one. How we understand it? Look,
Because of the FIDS.
bravo. Look, guys, the FMGC 1 and 2, you see, are connected where? To the FAC 1. And after the FAC 1 is connected to the FAC 2. You get it? To the two
Okay.
channels. These computers, they have the same part number, guys. You change this one, you place it here, no problem. It has inside also in these feeds. It's not belong to the, just say it belongs
To the
the
computer.
aircraft position. Yes, to the aircraft position. And the computer, it has it. And the FAC 1 has it and FAC 2 has it. But at the FAC 2 place, we don't use the feeds. Okay. At the place that we place it. The rest, as you can understand, is the same. You can go here to the MCDU, 1 and 2. You can perform the test, one of them. You cannot make it for both of them at the same time. Eh? So, let's speak a little bit about it. And after we will go. Mhm. Okay, guys, I will not go further. Unfortunately, tomorrow we will not continue together. So the middle is this one. So we're going to see in some videos also to understand it better. We're going to make a review also. So the auto flight system is a type 1 system. What means, guys? Did you learn what is type 1?
Yes, sir.
Type 1 computer.
It gives so many options like last leg report, previous leg report, troubleshooting data, system test, and ground scanning.
So, bravo, nice. Type 1, what is, guys? It is a one computer that he is intelligent. It is intelligent computer. What means this? That he has a memory of 64 legs, okay? And he's intelligent. You can tell him, do you have a problem? Yes, I have a problem. And I will tell you exactly what is my problem. And he will inform me exactly what is the problem. It has all of these data, the previous leg reports, last leg reports, eh? Troubleshooting data, pin, it can tell you the configuration, yes, the part number, the serial number. You have the class 3 faults, everything. Intelligent computer. The type 2, you remember what it is?
Gives only three things: last leg report, previous leg report, and class 3 faults and system test.
Just to tell you, this doesn't have a lot of memory. Hmm? It has the last leg report. And it is intelligent. You can make a test and can tell you exactly what is the problem. And the class 3, type 3, sorry, type 3
Only reset or on off.
test. It's a dumb idiot. Doesn't have memory at all. It's like a goldfish. No memory. I have no idea where am I, what I'm doing. You just push the test and you say, okay, dumb. Oh, I'm okay. And that's it. You're okay, I'm okay. You are okay, I'm not okay. What you have, I have no idea. Search it. Why? Because we don't need to be intelligent, this computer. If it will tell you that I'm not okay, that's it, you change it. You don't need to make it further. It's not because it's an idiot, it doesn't need to be intelligent, okay? But this one, the FAC one, the FMGCs guys, it's intelligent computer. That's why they are type 1. The line maintenance of AFS is based on the use of the fault isolation here and detection system, the FITS, active in the FAC 1 and of the bytes located in the various AFS computers. Access to the fault data is made through the multipurpose control and display units through the MCDUs via, again, the CFDIU. Like for other systems, the CFDIU works in normal mode and menu mode. So the feeds is a card physically located in each FAC. Both FACs are interchangeable, but only the FAC1 feeds is active due to a side signal, as I told you. Side 1 signal. The feeds is used as a system byte to concentrate maintenance information. The feeds is leaked in acquisition and reception of the CFDIU and is connected to the bytes of the various AFS computers. It receives commands from the CFDIU, interprets these commands and transfer them, if applicable, to the various byte concerns. It receives malfunction reports from bytes, manages these reports, and if applicable, consolidates the byte diagnosis, occurrence, correlation, and generates a fault message which is sent to the CFDIU. If the feed fails, the bytes continues to work and the results can be read in the SOP after FAC1 change. The normal mode function is the same as in other systems. In addition to the usual system report functions, the menu mode gives access to ground scan, AFS test, and land test. The byte now, according to its internal architecture, each AFS line receptacle unit, LRU, okay, each of them, had several bytes. The basic purpose of a byte is to detect, isolate, memorize failures. The FCU and the MCDU bytes only perform the detection task. The failure detection is triggered by a specific event listed in the maintenance manual. Example of a flight guidance FG and command trigger event ILS on failure. So the failure localization corresponds to an analysis process to identify the source of the failure. FAC FM and FG, flight management flight guidance byte, as the FAC and the flight guidance have a byte in the command and the monitor mon sides. The fault analysis is generally made on each side, and the synthesis is made on the command side. Each byte memorizes the result of the analysis, the failure context, the flight leg number, the time, the date of each given failure. Then the byte send the result of the analysis with a maximum of 2 suspected LRUs in the order of probability to the feeds. The FCU byte, each FCU byte computes the maintenance status of each related part and permanently send the maintenance data to the flight guidance command part. The MCDU bytes. The MCDU does the test on each processor memory and display unit. If a failure found by the MCDU byte, the fail annotation come here, guys, and the display is blank. The MCDU fail output script is set and sent to the FM part and then to the flight guidance 1, flight guidance 2 command parts to the cross talk bus. Let's see about the ground scanning. So we have this ground report, the ground report function, which displays failures recorded in ground area of the feeds memory. We have the present failure scan function, which is used to isolate failures present when the function is selected. The manufacturer, for development purposes, use the program page. The AFS test. The AFS test, as we can see, we check the AFS LRU before removal, and we check the AFS LRUs before installation, and we get the troubleshooting event if the test is okay. So here, guys, is FAC1, FAC2 pass, says FMGC1, FMGC2 pass. So this is the auto flight system test report, and this is completed. It will tell you here the leg, the date, and the time. The landing test. The land test gives the test availability of the landing mode and equipment required to obtain Category 3. These are several successive pages in which actions, checks, and answers are requested from maintenance. So this is the AFS land test, number 5 action of the FCU, engage flight director 1 and 2, ILS 1 and 2, auto thrust, approach, and autopilot 1 and 2. Check on the PD 1 and 2, speed, cat 3 dual, and autopilot 1 and 2, 1 FD and 2, and auto thrust. If you check this and you have these indications here, you place yes and the test passes. If not, you need to perform further actions to find where is the mistake. Okay. Okay, guys, let's continue. One second, only give me to check the program for sure. So tomorrow also you have the auto flight system, am I right?
Yes, sir. Tomorrow we have 5 hours for auto
5
flight.
hours or 6?
5 hours.
1 second. Where it is? Just to be sure, guys, not make you more or less serious. I will not continue if I will continue. I don't need to make anything. I will know where I will stop and where I will go. For tomorrow, yes. 1 second, you're right. You have 5 hours, the 22, and 1 hour, the 23. Okay.
Was that, sir?
Yes. 5 hours about the auto flight, 5 hours you have, and you have around 1 hour for the 23 chapter.
Okay.
So today at least I will go till
Your voice is breaking.
yeah, I didn't continue. I'm thinking to finish you at 73 page. So we are very nice. The next instructor will continue. Just we must inform him that we finish at 73. Let's see in this one. And after I'm going to place you some videos, guys, which will help you a lot to understand the system a little bit better, or to make, in this case, a small, I can say, a small check again from the system. Until now, you have any question, guys?
Okay, it's okay.
It's okay. You prefer a little bit to see this module. One moment, yes. You prefer to see the CBD or this one? What you wish?
CBT would be nice.
CBT, yeah. Please.
CBD, guys. I think that the CBD help you a lot.
Yes.
You won't be there tomorrow, sir?
No,
Okay.
unfortunately, no. I would like to continue with you guys at least.